Let's calculate the test duration and sample size for our A/B test on the cart page for the merchandise store. If we can run an A/B test and for how long depends on the number of website visitors and conversions going through your test page. A rule of thumb is that you need at least 1,000 visitors and 250 conversions for each test variation in your A/B test. But the fact is, I barely see these numbers work. To make these numbers statistically valid, you need to find a big uplift in your conversion rates. The change you make in the variation needs to result in a huge increase in your conversions. If you work with 1,000 conversions per test variation with a 25% conversion rate, you need to find an uplift in your conversion rates of at least 18% to make it statistically valid. And 18% is of course big. Just imagine 18% extra revenue coming in through your website. Of course, I've seen it happen in some A/B tests, but it is not very likely that you find an uplift of 18% in every test. When you work with 10,000 conversions per test variation, you could detect an uplift of 3% in your conversion rates. And this all has to do with statistics. The more website visitors and conversions going through your test page, the smaller statistically significant valid uplift you can detect. In this lesson and the following lessons, we will check out a calculator and Google Sheet for your pre-test calculations. Besides the numbers you get from the calculators, you also want to run your A/B test for full business cycles, so for full weeks. Run your A/B tests for at least 1 week to a maximum of 4 to 6 weeks. You don't want to run your A/B test just on the weekend, for instance, because the behavior of your website visitor can be very different on a Monday and a Tuesday. So the impact you see in your A/B test on the weekend could be very different from the other days of the week. Besides that, you also do not want to test any longer than 6 weeks, because people delete their cookies. If you test for longer than 6 weeks, there's a big chance that visitors will see both the variation and the control. Because people delete their cookies, and this pollutes your data and makes your results less trustworthy. To stay on the safe side, I prefer a maximum of 4 weeks. But if you have low traffic and conversions on your page, you could test for 6 weeks. To calculate the number of visitors you need in a test, also called the sample size, and to calculate the test duration, we will use a useful and free tool from Spiro. You can find a link to the calculator in the lecture resources. Before we start filling out these numbers, and we will do so for our test on the merchandise store, you first have to be familiar with some of the terms in the tool. Let's start with the confidence level. The confidence level or significance level is the probability of getting a similar or larger difference when repeating the experiment. So it is the percentage of times your experiment will show the same outcome when you repeat the experiment. If we set the confidence level to 90%, in 90% of the cases, the outcome of the A/B test will be the same or better. In other words, if there's no difference in the test, you are willing to make a type 1 error 10% of the time. At this stage, you do not want to put this number below 90%. However, if you have sufficient traffic on your website, you might want to set it to 95%. More traffic in your A/B tests decrease the chance of making a wrong decision. Next is the power. The power is the likelihood that your experiment will detect an effect when there is an effect to be detected. The higher the power, the lower the probability of a type 2 error. For A/B testing, you want to set the power to 80%. In other words, if there's a difference in the test, you're willing to make a type 2 error 20% of the time. For A/B testing, setting the power to 80% is standard practice, and I also recommend doing so. Finally, we have the minimal detectable effect, in short, MDE. This is the minimum difference that you can reliably detect in your test results. given the power of the test. So with an MDE of 5%, you can find a statistically valid uplift of 5% or higher in your experiment. When the uplift is below 5%, there's a bigger chance for a type 1 error. The lower your MDE, the higher the impact you can make with your A/B tests. Because a low MDE means you can detect smaller significant changes. Now you might wonder, what is a good MDE? In the best situation, I strive for an MDE below 5%. An MDE below 5% is perfect for finding small, significant uplifts in your conversion rates. An MDE between 5 and 10% is good for finding bigger uplifts. Keep in mind that with an MDE between 5 and 10%, you want to make big changes in your variation to potentially find a big uplift. Preferably make these changes above the fold so as many visitors as possible will see the changes you made. When you have an MDE between 10 and 15 or 20%, you need to make huge changes in your variation. Ideally, I do not test on pages with such a high MDE, because it is not very likely that you find such an uplift with a single A/B test. But if you have a low traffic website and MDEs do not get much lower than this, do test huge changes and make sure you have solid evidence for these changes to work from your optimization research. So, confidence level, power, and MDE. It is standard practice to set the power to 80% and the confidence level to 90 or 95% when doing your pre-test calculations. I added some articles in the lecture resources if you want to know more about these statistics. If you are not a fan of statistics, simply use these standard practices and you will have trustworthy A/B tests. So let's calculate the sample size and test duration for our merchandise store test together.